So on to question 2. A customer who wants to hire a car from a certain car hire company needs to specify 2 criteria: size of the car, A or B, type of air conditioning, with climate control or without. A statistical study carried out on a large... Now, I'm going to start highlighting things that I think are important. On a large number of customers found that... Now, this sounds like it could be, we could use a binomial distribution. 6% of customers hire a size A car, and 20% of those opt for climate control. 6% of those who choose a size B car choose climate control. Draw a tree diagram for the above situation. This should be fairly straightforward, okay? So we have 2 options where we have 6% of hire a car, a size A car, okay? That's A, and that's 60%. Or they hire a size B car, and that would be 40%. From A, we've got 2 options. They can either have climate control, or they do not have climate and do not have climate. Now, it says 6% of those who choose a size B car choose climate control. So 6% of those who choose a... Okay, so that's 6% here. And this is obviously 40%. But how do I do the top branch? Well, we need to maybe... If we use a two-way table, oh sorry, no, am I being silly? 20% of these opt for climate control. It tells us everything. Oh, you owe me, class. You owe me something quite big, a meal or something, or maybe better. There we go, 4 marks. Part 2. I know, 4 marks for that. I'm so generous. Part 2. A customer is chosen at random. Find the probability that they have chosen a size A car with climate control. Okay, so we have to do 0.6 times 0.2, which is equal to 0.12, which is equal to 12%, and that is worth 2 marks. Part 3. Oh, sorry, that's my mistake. As always, that's part A. This is part B. So part B, the customer has chosen a car with climate control. So we can have probability of A intersection climate control plus probability of B choose climate control, which is equal to 0.6 times 0.2 plus 0.4 times 0.6, which is equal to 0.12 at 0.24, which is equal to 0.36, which is equal to 36%. And that's equal to 2 marks again. And C, they have a size B car given that the car chosen had climate control. So we know that the car had to have climate control. So this is going to be over 0.36. So it's going to be 0.24 divided by 0.36. Now I'm going to show a bit more working for all this. You could say it is the probability of B to C over the probability which is equal to 0.24 over 0.12 add 0.24 is equal to 2/3, and that's worth 3 marks. Part D. Oh, I apologize again. Let's go for part 2. No, part 3 even. We assume that the number of customers is big enough in order to say that the customer choices are independent of each other. Okay, definitely we're looking at this phrase here. Oops. Oh, why is it not highlight? Highlight. Okay, it's not allowing me to highlight. But I wanted to highlight to say it was in, because of that we know it's a binomial distribution. So we can say possibly that we have that. The company has 50 customers on a certain day. So we have 50 customers on a certain day. Find the probability that exactly 5 cars with climate control will have been chosen. So the probability with a car with climate control is what we have part 2 part B. Part 2 part B is 0.36. So and n is equal to 5. Well, the distribution actually, we want to have 5. It's going to be, let's do this properly. So if I was going to use the actual formulae, exactly 5 cars are chosen. So we have probability that x is equal to 5. We could say that's equal to 50, choose 5, times by 0.36 to the power of 5 times 0.64, because that's what p is, to the power of 45. On the calculator, you can just do menu, statistics, no, sorry, my mistake, probability, distributions, binomial PDF, number of trials is 50. So I should have said n is equal to 50 up there. Probability of success is 0.36, that's what we're choosing, and x value is 5. So it's equal to 0.00024. And it does round to 6 figs. That was part A. And that was worth 3 marks. Part B, between 10 and 20 cars, so that does not include 10 and it doesn't include 20, so I need to have 11, 12, 13. So I'm going to use a cumulative, I'm going to use a cumulative one, so I want to have 11 to 20. Quite a few ways of doing this. Very quickly, I'm going to use the binom CDF function for everything. So, so binom CDF menu 5 E, number of trials 50, probability of success is still 0.36. Lower bound is 11, upper bound is 19. And that's equal to 0.00016. Again, 3 marks. But what I could have done, if I really wanted to do this, I could have done it like this. I could have done 50, choose 11, times 0.36 to the power of 11 times 0.64 times 39 plus 50, choose 12, 0.36 to the power of 12 times 0.64 to the power of 38 plus, this is a quick way, it's how you can kind of show this without showing all the steps. And that's equal to, okay. Okay, part 4. Okay, part 4, we need to know that the probability has to be that we have at least one car with climate control has to be at least 0.99. So I need to calculate now. We know that at least one car is the same as the complementary as choosing 1 minus choosing no cars. So this is equal to n choose 0, where n is the number of cars that we have to have, times by probability of a success, choose 0, times by 0.64 to the power of n. Anything choose 0 is 1, so therefore we have 1 times 0.36, which is 1, times 0.64 n. Therefore we have 1 minus 0.64 to the power of n is got to be greater than or equal to 0.99. So 0.0, I'm taking away 0.99 from 1, so 0.01 is greater than or equal to 0.64, adding that across. I can solve that. Solve open brackets, 0.01 is greater than or equal to 0.64 to the power of n, comma n, so n is equal to, n has got to be greater than or equal to 10.3189. So it says find out how many cars need to be hired so that the probability that at least one car with climate control is chosen is at least 0.99, and the answer is therefore not 10, 11 cars. If I put 10 into the formula, then it wouldn't quite work. Okay, and that's